All right, let's take a look at case 4. Case 4 is when the denominator is a repeated irreducible quadratic factor. So the denominator is quadratic, whose solutions are complex, and it's raised to some power n, where n is an integer greater than or equal to 2. The partial fraction decomposition is going to be in the form a1x plus b sub 1 divided by ax squared plus bx plus c plus a sub 2x plus b sub 2 divided by ax squared plus bx plus c squared plus a sub n x plus b sub n all over ax squared plus bx plus c to the n. So just keep in mind that when your denominator is quadratic, the numerator is linear, and when it's this repeated form, you're going to have as many factors as you have as an exponent. So when we have an example like x squared minus 5x minus 2 all over x squared plus 4, we can express this as ax plus b over x squared plus 4 plus cx plus d over x squared plus 4 to the second. And so I don't want to keep track of all the subscripts, so that's why I'm just using like A, B, C, D. And if it was longer, I would have E, F, G. And so we're going to follow that same pattern that we did in the other problems. We need to make all the denominators the same, so we can multiply this term by x squared plus 4 over x squared plus 4. Now that all of the denominators are the same, the denominators cancel, and I'll just be left with the numerator. This leaves me with x squared minus 5x minus 2 equaling, we'll need to distribute and multiply here. So it'll be ax cubed plus bx squared plus 4ax plus 4b, and then plus our cx plus d. We still want to equate the coefficients just like before, so we may want to think about this as 0x cubed plus x squared minus 5x minus 2 equaling ax cubed. There's only the one bx squared. And we have a 4a plus c times x plus 4b plus d. Alright, so still equating those coefficients, these are the exact same, so that means a has to equal 0. B would equal 1. And 4a plus c is negative 5. And negative 2 is 4b plus d. My d's are not liking me, and that's negative 2. Alright, so if a is 0, then that term is gone. So we get c is negative 5. If b is 1, then we'll end up with 4 plus d equals, and this is supposed to be negative 2. D, negative 2. And so that means d is equal to negative 6. Let's go through. We got a 0, b is 1, we need to find C. Oh, nope, C is -5 and D is -6. So our expression Alright, so I erased everything and rewrote what we ended up getting. We ended up with A being 0, so then that's why the linear part is gone, and since B was equal to 1, we have 1 over x squared plus 4. We found C to be -5 and D to be -6, and so this is our rational expression that we would have to add in order to get this back. Alright, I hope you found this helpful, and just make sure that you know how to recognize those 4 cases and know how to set up the partial fraction decomposition. Alright, see you later, class.